All right, let's talk about Intel's SSD lineup. There are three drives. There's the 320, the 510, and the 710. Now, the 320, it's the mainstream drive. This is the drive you buy if you just want an SSD and you don't care about having the absolute best performance. It's still going to be a lot faster than the mechanical drive. It's the most affordable drive that Intel offers. It uses Intel's own controller with Intel's own NAND and Intel's own firmware. It goes through Intel's own validation process. It's a good overall drive. Now, this drive works both in the client consumer space as well as the enterprise space. You can actually throw these things in servers if you have a light enough workload. Above that, you've got the 510. The 510 was kind of Intel's answer to folks who said that, hey, look, we actually do want the fastest performing SSD in the world. While the 510 isn't technically that, it comes very close. It's second to only the Sandforce SF2281. It actually uses a Marvell controller. Intel, for whatever reason, hasn't been able to put out a 6 gigabit controller of its own. I suspect it's working on it and for whatever reason kept getting delayed, or there were bugs in the initial revision, what have you. For whatever reason, rather than staying absent from that market for another year, Intel turned to Marvell. Marvell supplies the controller, but Intel still supplies the firmware, the NAND, the validation, puts Intel's name on it. And overall, they say it should be no less reliable than the old X25Ms. That being said, the 320, the entry-level drive, Intel still says that should be a bit more reliable. If you're a consumer and you're deciding between the two, if you don't have a good 6 gigabit controller, if you're not running on Sandy Bridge, if you're using anything else, the 320 is a good drive. It's solid, it gets the job done, and it should be very reliable and very compatible. If you do want that extra edge, especially if you're doing a lot of large file transfers, like moving movies around, moving large archives around, things like that, the 510, it does offer a noticeable performance advantage. Again, if you've got like a Sandy Bridge or something that has a good 6 gigabit controller on board. But what if you're outfitting servers? What if you're building out your data center, or you're moving away from mechanical storage and want SSDs? Well, you can use the 320. If you don't have a really write-intensive workload, you got to remember the 320 uses standard MLC NAND. So each cell of each bit that you write to it, right, is written to a cell of MLC NAND. Now, those cells can withstand about 3,000 to 5,000 program erase cycles. That means you write to the NAND, eventually come back and erase it, and get ready to write to it again. You can do that about 3,000 to 5,000 times. For desktop users, it's a non-issue. Doesn't matter what your workload is. If you're doing normal desktop stuff on your computer, even if you're a power user, you'll never cycle through, at least on a drive with a good controller, you'll never meet 3,000. On the enterprise, again, you have to profile your workload. It depends what you're doing. For a lot of cases, if you up the spare area on these drives, a 320 will do just fine on a server. But what about the upper echelon of enterprise deployment? What about the video caching servers or the database servers that have to deal with thousands of concurrent users doing tons of writes, tons of table updates? For them, 3,000 to 5,000 cycles isn't enough. You'll be killing drives every few months. There has to be an alternative. And there actually used to be. You could get the X25E, use a single cell NAND. That's 1 bit per cell, much higher endurance, much more write cycles. Right, so the 3,000 to 5,000 on MLC today, with the first generation SLC that Intel introduced with the X25E, you could write to each cell 100,000 times and still be okay. And that was more than enough for a lot of enterprise workloads. And the unfortunate problem was cost. When the X25E debuted, it was $15 per gigabyte. Even today, the largest capacity is only 64 gigs, and it's still over $12 a gigabyte. One of those drives can still replace tons of mechanical disks, but it's not desirable, especially if you need more storage than you can get from 64 gigs. We do all of our data center infrastructure in-house, so AnandTech is all hosted on servers that we've built, that we've deployed. And even for us, we have a number of X25Es. Space is a concern. If possible, we would like to go to something that just simply had more storage capacity. But in terms of affordability, you don't really have that option if you look at SLC. The holy grail has always been to get MLC into the enterprise. But again, you've got that 3,000 to 5,000 cycle limitation, not super desirable. So what Intel's done, and what a number of NAND manufacturers are looking at, is sort of binning MLC into the normal stuff that goes into client drives, and then this ultra high-end quality, the best of the best on each wafer. In the past, this stuff's been called enterprise MLC or eMLC, and Intel's branded it MLC with high endurance technology. Through a bunch of binning and testing and selective processes, they're able to separate the top X% of each MLC wafer into this high endurance technology MLC. And these MLC cells are good for, we calculated it to be about 40 to 60,000 cycles. So still not quite as good as SLC, but far better than standard MLC. And the beauty is it's still fundamentally MLC, so you get much, much better cost. As I mentioned, we're talking about $6.50 per gigabyte for the 710, which is obviously a lot higher than standard MLC, but way, way lower than SLC, and actually competitive when you look at the enterprise space. And that's actually what's in the SSD 710. It's this high endurance technology MLC. It offers nearly the same endurance rating as the X25E. So the X25E, you could write to it between 1 to 2 petabytes over its life, and it'd be totally fine. The 710 depends on the capacity, but you're looking at 500 terabytes to 1.1 petabytes of writes that you can perform. And if you up spare area on these drives, you can get those numbers as high as 1.5 petabytes. Again, you're within the realm of SLC without paying the cost, and you have much better capacity options. So the X25E used to be available at 32 and 64 gigabytes. This thing, the 710, you can get at 100, 200, and 300 gigabytes. Now, Intel sent us a 200 gig drive. I opened it up. So the first thing I noticed was there's actually way more than 200 gigs of NAND in here. Spare area is very, very common. It's a way of keeping write amplification in check. But I've never seen a drive with this much spare area. The 200 gig drive actually has 320 gigabytes of NAND on board. And that upper 120 gigabytes, actually a little more than that, that's all spare area. That's just used as internal scratch for dealing with read modify writes and dealing with cleaning up garbage collection, stuff like that. In the end, it keeps write amplification very low and helps you get to those 1 petabyte plus endurance ratings. Performance-wise, as long as you're not doing super heavy random writes, it's indistinguishable from the X25E. Now, the X25E still uses SLC NAND. So you got to remember, SLC NAND is, in terms of write latency, it's about 3x the speed of MLC. So if you're doing a lot of small file random writes, the X25E is still going to be faster. In our Oracle Swing Bench test, we measured about a 25% increase in throughput and a 30% decrease in service time going from the 710 to the X25E. Now, that's not great, but the beauty of it is because the 710 is cheaper, if you actually do depend on performance to the degree where you would notice that in your workload and you don't simply need more capacity, you can always deploy more of the 710s in your RAID array at the same cost as the X25E and have greater capacity and equal performance. For everyone else in the enterprise space, like I said, you'll have competitive performance to the X25E, but just better capacity and at a lower cost. Overall, I think that's the market that this thing's going for. It's a drop-in replacement almost for X25E users, or people who needed the X25E but couldn't really make the jump because of capacity constraints. The 710 addresses all of that. What I'm missing from the 710 is the ability to actually push performance further. You know, in our enterprise tests, if you look at the SandForce 2000 series of controllers, they're just much, much faster than this. What SandForce doesn't have is Intel's track record for reliability and just dependability. Now, if SandForce can address that, that's just a far more attractive architecture for use in the enterprise. Now, the real question is, can Intel offer a better performing enterprise solution than the 710 quicker than SandForce can address its reliability concerns? And to be honest, I would say that, yeah, Intel should be able to do that. But, you know, I also said that Intel would probably be able to have a 6 gigabit drive out by now. So it really remains to be seen. But for users today, if you're an enterprise customer that are looking to deploy something X25E class in terms of performance, in terms of reliability, the 710 is an obvious replacement.